Okay, so section 1.2 is entitled Functions and Graphs. Just before we start out with the definition of functions first, let's look at the definition of a relation. I know you can't see this too well because it's actually pulsing, but here the relation is a correspondence between a first set called a domain and a second set called a range, such that each member of the domain corresponds to at least one member of the range. So what a relation means in mathematics is that you have a group of numbers called your domain. And it doesn't matter what they are, whether they're real numbers or integers or any of that kind of stuff. But then you also have a range, and that's the output values that you have. And there's a relation between these two, where you map one number to the domain. Okay? Now, when you have a relation, anything can happen. You can have two numbers mapped to one number or one number mapped to two numbers. But a specific type of relation is called a function. And a function is a correspondence between the first set called the domain and a second set called the range, such that each member of the domain corresponds to exactly one member of the range. And this is the important part of the definition, is that it corresponds to just exactly one. So what that means is in an actual function, you still have your domain and you still have your range. But for every number you have here, it maps to exactly one number over here. It only maps to one. It does not, and this is the big does not, map to two numbers. In other words, for every input, there's one output. And that's pretty much the layman's definition for what a function is. Now, in mathematics, we have a notation for a function that is very helpful. We use something called f of x. And so we say f of x. And so this is actually called the function of x. Now, you can either use other types of g of x, h of x, you can use b of g. It does not matter what it is. But what f represents is the function, and the x, what's inside the parentheses, that represents what the actual input is. A simple example of a function would be a linear function, which we will talk about earlier. And let's say we had f of x is equal to 2x plus 3. And so the way this notation works is that x here and this x here mean the same value. So if I had f of 2, that's going to equal to 2 times 2 plus 3. So this value gets substituted here, and then you can simplify the math if you want. Okay? The moral of the story here is it doesn't matter what it is. Let's say I had f of z, and I'm putting that into my function. I'm going to have 2 times z plus 3. So it's a simple just replacement of the actual variable. You could do f of 2x. You simply put that in, 2 times 2x plus 3, and then simplify as you need to. The one that we're going to use later on is going to be something called the difference quotient. And we're going to substitute f of x plus h. And so remember that this is, even though this is an expression and not just a simple variable, you substitute it the same exact way. We're going to do 2 times the quantity x plus h. Now make sure you use parentheses here because we're going to have to distribute that 2 here and here. And then we still have the plus 3. So now when we simplify it using our distributive property, we're going to do 2x plus 2h plus 3, and then we're going to be done with that. Okay?